You've chosen answer C, that the upper plate is stationary while the lower plate is moving to the left. C is indeed the correct answer, and let's examine why. If the plates are stationary, then a pressure gradient would be necessary to create flow between these plates. We'd have to have some pressure, P1 and P2, and we'd either have our pressure, and let's say the x direction, we'll give this x direction. This would have to either be less than 0, or our pressure gradient would have to be greater than 0. Now this curved region here indicates that we do have a pressure gradient between these plates that is inducing the flow. Now the pressure gradient in this case is negative because we are having flow going from left to right, so the pressure P1 is going to be greater than P2, inducing that flow. However, you do see that we have some velocity near the bottom plate acting opposite to this pressure gradient. The no-slip boundary condition means the fluid takes on the velocity of the surface. Now at the top plate we see that the velocity is 0, which would indicate that our plate is stationary. At the bottom plate we have a velocity acting in the direction to the left, which indicates that our plate must be moving in the direction to the left. Now if we didn't have a pressure drop and we just had a stationary top plate and a bottom plate that was moving to the left, we would get a form of Couette flow that would basically be a shear induced flow, where we would get our velocity profile acting to the left and it'd be a linear relationship between the two plates. However, since we do not have that occurring, and we do have this curved region, we also have a pressure induced flow from left to right.